Hello class, in this video I'll be introducing partial derivatives. Let's begin. So here's a function, and the values of this function depend on two variables. It depends on x, and it depends on y. So I have two questions to ask. How does f change if x is held constant while y varies? Another question I can ask, how does f change if y is held constant while x varies? Well, both of these questions can be answered using partial derivatives. We will not be going into the formal definition of a partial derivative in this class, just the informal definition. So here we go. The partial derivative of f with respect to x is the derivative of f obtained by treating x as a variable and y as a constant. Or sometimes you'll hear me say y is a coefficient. The partial derivative of f with respect to y is the derivative of f obtained by treating y as a variable and x as a constant. And sometimes you'll hear me say x is a coefficient. All right, as for the notation, there are two main types of notation that you're going to see. The first two look like this. So for the notation in black, that is the first order partial derivative with respect to x. For the notation in navy blue, that represents the first order partial derivative with respect to y. Here's another notation for a partial derivative with respect to x. And here is another notation for the partial derivative with respect to y. All right, so what do derivatives do? Well, derivatives measure rates of change. Derivatives measure slopes of tangent lines. So here we have a surface, and there's a tangent line at the point AB, comma, f of AB. Now, the tangent line is traveling in the direction of the x-axis. The slope of the tangent line can be measured by evaluating the first order partial derivative with respect to x at AB. So that is this line that I want to trace in pink. I want to place another point here, and I want to place a tangent line through that point. And we're going to call this CD, f of CD. And I'm going to write the statement in blue. The tangent line is traveling in the direction of the y-axis. The slope of the tangent line can be measured by evaluating the first order partial derivative with respect to y at the coordinate C, D. In the next couple of videos, I'm going to be showing you how to find both first order partial derivatives of a function.